Okay, so this video is going to help with indeterminate form. And remember, indeterminate form is where you end up with a 0 over a 0, or it could end up being an infinity over infinity, which is in the next section. So we'll have some like that as well. It could be negative infinity over negative infinity as well. So those forms are like, I don't know, I can't see the limit. Like I can't just put the number in and get the answer. So let's look at two examples and two different ways to solve these. This first one right now, if we put this 3 in to the function, then we're going to see a 0 on top because 3 squared is 9. 9 times 6 is 54. 54 minus 54 is 0. And this one as well, 3 minus 3 is 0 as well. So we can see this is in the form 0 over 0. So we can't solve it the way it is. So we're going to rewrite this function using factoring and cancel common factors so that we can put the 3 in and not get a 0 over 0. So if we look at the top here, we can see that you can take a 6 out of that. So 6 divided out would leave x squared minus 9. And the bottom is still just x minus 3. And then we can see that difference of squares, and we can factor that x squared minus 9 into x plus 3 and x minus 3. And then again, we still have the x minus 3 on the bottom. And then we can see we have a common factor there, and that will reduce our function and change it to be 6 times x plus 3. Now, this is still the same function. It's just simplified and in reduced form. Okay, so now I can take the limit as x approaches 3 of this new function. So 6 times 3 plus 3. I put the 3 in here, right? So it looks like this. So 3 plus 3 is 6. 6 times 6 is 36. Okay, so our final answer is 36. So we got that by factoring. This is the most common in business. You might see a formula like this second one, just maybe not as often. So this one looks very different. Well, it doesn't look very different, but it has a square root in it. So it makes it not factorable. So if I put a 0 in right now, I would put a 0 here, and that's going to give me 0 plus 1, which is 1. 1 square root of 1 is 1. 1 minus 1 is 0. And then 0 in for h is just 0. So right now it is 0 over 0. So I didn't get a number. Darn. If I just got a number, right, I'd just be done. So this one has to use the idea of rationalizing the denominator. And this time we're going to rationalize the numerator, which is very different. Well, it's done the same, but we just, in algebra, we always called it rationalizing the denominator. So let's remind ourselves what that looks like. So the top right now is 12h plus 1 minus 1, and the bottom is just h. So I'm going to multiply by the conjugate on the top. The conjugate is where you change the sign in between the two terms. So I'm going to make that a plus. So I'm going to times by the square root of 12h plus 1 plus 1, because it was a minus. Now we're going to make it plus. If I multiply the top by that, I have to multiply the bottom by that as well. So I'm multiplying by a 1 here. Okay. And so I'm going to use the idea of FOIL. So make a big parenthesis here just so that you can see it better. And here as well, if you want. Okay, so we're going to multiply straight across on our numerators. So we start with this one times this one. So x square root of xh plus 1 times the square root of xh plus 1. We can multiply them because they both have a square root. So 12h plus 1 times 12h plus 1 is 12h plus 1 squared. Don't multiply it out. And this is all under the square root. Why don't we want to multiply it out? Because the square root and the square undo each other. So we don't want to multiply that out. Okay, then the next one is this term times by 1. So that's just going to be a positive square root of 12h plus 1. Then take this negative 1 times the first term, which would just be negative 1 times the square root of 12h plus 1, which is just negative 12h plus 1. Then negative 1 times a positive 1 is a negative 1. Okay, and then on the denominator, h times the square root of 12h plus 1 plus 1. I'm not going to distribute. I mean, you can, but then you'll have to take it back out. So it's kind of a pain. So look at the top. This cancels this. The square and the square root undo each other. So the first term is just 12h plus 1. And then you still have this minus 1 over here. And then on the bottom, I have the h times still the square root here of 12h plus 1 plus 1. And you will see that this plus 1 and minus 1 go to 0. And you should also see that this h here and this h here will cancel because they're both factored into the front. Because right now, if I put a 0 in, I'm going to have 0 over 0 because it's still in that form. So h's have to cancel as well. So the final form is just a number on top, 12. Oh, it looks like C2, but it's a 1. And the bottom is the square root of 12h plus 1 plus 1. Okay, so this is finally in a form that we can use to do our limit. So we put in our 0, and I would have just 12 on top. So here, 12 times 0 is 0, plus 1 is 1, square root of 1 is 1. So I get 2 because 1 plus 1 is 2. So that's 6 when I reduce. So my final answer is 6. It takes a little bit of algebra if you have to use the conjugate method. It's rationalizing the numerator to rewrite it. Okay, so all we did is rewrite it by using this idea here of the conjugate and multiplying by that conjugate. Okay, those are our 2 methods that we're going to use. All right, hopefully that helped ya.